Wait, 1 through 5.
Hey, I'm feeling like a one-line off day. How's that sound? I want to put it in a mousetrap. Yeah.
Did you just say all the problems except 7?
Yeah, but that would be actually more to write.
Do page 94 problem except 6.
Okay.
Or no 6.
1 through 9, no 6. I still feel like that would be just as much.
Try it.
That'd probably be more.
Try
I mean,
it.
this is only 1, 2, 3, 4, 5, 6, 7, 8 spaces.
N-O space 6.
You said all problems.
Do page 94 problem. No 6.
And people would be confused about that. They would be. That's Everett. Yes, it may. All right. Here we go. Chapter 5.
I'll write that on.
We're going to talk about Sir Isaac Newton and his forces. We'll talk about Newton's laws, which you have heard before. I know that. There are 3 laws by the man known as Sir Isaac Newton. Okay. Why don't you get that homework assignment from somebody next to you, Everett? A few things. This is going to be the least amount of history we'll really talk about. It's really just kind of one slide here. Seeing some similar names up there. I mentioned Newton. I don't know if we've actually put him in your notes yet. We've talked about Galileo last chapter. I don't think we've mentioned the first guy there. Archimedes. So Archimedes was the first to write about forces. I don't know if that means he was the first to define the word force. It's kind of vague, I guess. I don't know if your reading talks about that. Oh, let's take a gander. What are we, chapter 5? During the 3rd century BC, Archimedes, a Greek mathematician, engineer, and astronomer, wow, pretty smart dude, was the first to write about the causes of motion. So I'm guessing they hadn't defined forces, but he wrote about what caused motion, and we know now that for motion to occur, you have to have a force. You're not going to get motion without a force. Now, you could have a net force of 0 and still get motion. But to get moving, you would have to have a force. Galileo, this is from last chapter, right? You remember Galileo envisioned, right? This is from last chapter, right? We talked about push and pull, Galileo last chapter? No, we didn't talk about push and pull? Maybe not. You may be right. We just talked about Galileo saying...
You said that he did how things move first before.
Okay, so we never actually gave a definition. So that's kind of our definition for force, is a push or a pull. There really isn't a better way to define force unless you say a mass that's accelerating is the result of a force. Okay? And then we will talk quite a bit about Newton, all his laws, and how that affects motion. So, force. We will describe it as a push or pull. There's not really a better definition than this. It's really basically that. Usually when we think push, we think away, and when we think pull, we think towards. So really they're the same idea. So, somebody want to volunteer to read B? Shane, go ahead.
Acts in a single direction with a certain size or magnitude.
Okay, acts in a single direction with a certain size or magnitude. So, what does that tell us about a force? Coming from last chapter. It's a vector quantity. Because it has direction and magnitude. Remember, magnitude is just the amount or the size. So we could represent forces with a what? Arrow. That was also on your test, wasn't it? And on your Kahoot. Right before your test. Hopefully you got that one right. So, it's a vector quantity. You don't have to put the next thing in. I'm just going to refer to force as F. There's nothing else that has the variable F. Ooh! We got another variable! Put it in the back of your book. Guys, did you know that the variables that we've already had from last chapter, we're going to continue to use this chapter? So I'm hoping you didn't just shrug me off when I said, hey, you need to know these. And then you're like, oh, this chapter's done, I don't need to know them anymore. I didn't really actually have to know them. No, you still need to know them. Are we going to use acceleration this chapter? Absolutely. We're going to use time this chapter? You betcha. How about velocity? Of course. You betcha. So, you can go into your back of your book, and we've got the name, which is a force. What's its symbol? I'm just going to say F. Usually they put an arrow when it is a vector quantity, but there's nothing else that has the variable F, so I'm just going to call it F. Most common units. Have I said anything about the units yet?
No.
Okay, that'll probably be on the next slide, I'm guessing. Yeah. Your unit for force is a Newton. And it represents with an N.
I think you mentioned that.
Oh, yeah, I think I got rid of one thing. What's the matter, boy?
Just really tired.
And I turned the lights off.
Actually, that helps.
Really? Okay. Now, I don't think I've talked about derived units yet. Are you ready for that?
Yep.
Yeah, I don't think anything up to this point has had a derived unit. A Newton actually means something else. I'm going to show you what it means. So it says the SI unit for force is a Newton, and then it says in this course we're always going to assume a force is coming from some outside source. What I mean by that is we're not going to say an object exerts a force on himself. Does that make sense? Okay? So whenever we're studying forces, so if I want to study the forces acting on me right now, it's going to be the forces that outside sources are applying to me. Anybody have an idea what the force is that's applying on me right now? Gravity's force. Okay, there's actually one more. Bet you can't guess that one. Contact force? It is a type. Well, it is a type of contact force, but that's not what it's called. Good idea to guess. It's actually called normal force. Okay, and we'll get into that in this chapter. It's the force at the ground. The ground is actually pushing up on me. Did you know that? The ground is pushing up on me. And the reason why I know that is we know that a force causes an acceleration. So if gravity is pushing down on me or pulling me down, why am I not accelerating? Because there's an equal and opposite force pushing me up. So actually the net force on me right now is 0, and that's why I'm not moving. Crazy to think about it. We'll get into that. Okay, just trying to see if you have any previously learned knowledge. Now, we will get to this. Newton's second law says a force causes a mass to accelerate. You do not have to put this in yet. Okay, that's the infamous Fermat equation. Okay, we said the unit for force was what? Okay, so a Newton equals, what is the unit for mass? Any ideas? Close. It's actually a kilogram. And we should know the unit for acceleration. Meters per second squared.
Wow.
That's the symbol. So believe it or not, a Newton is a simplified unit of a kilogram times a meter per second squared. So whenever I say 12 newtons, I'm really saying 12 kilograms per meter times meter per second squared. But what they did is, instead of making you write a kilogram times a meter per second squared every time, they just said that we'll call that a Newton. Make sense? That's what a derived unit is. There's quite a few other derived units. We'll talk about that next chapter. A joule, the unit for energy, is a derived unit. Okay? So, continue. There are two categories of forces. Two categories of forces. And the next couple slides is where I will give you what those two categories of forces are. So you might want to think about how you want to organize your notes. If you want to, here's one category, here's the other category, or how you want to do it. Okay? First category, first type of forces, are contact forces. Another name for them is a mechanical force. This is the easiest type of force to understand. So what has to happen for a contact force to be in play? Gotta touch. Can't have a contact force without touching. So if I try to move Ethan with my brain, like using my psychic ability, that wouldn't be a contact force. Also doesn't ever happen. But in order for me to apply a contact force on Ethan, maybe like to his face, to fix his face, with my foot, I could just, Okay, so contact force is just one where you have to have contact. Real hard, Johnny? Man, there's a bunch of really easy things in physics. You should get 100% on every one of your tests, don't you think? Yes. So here are the types of contact forces. Yeah, put these in. There's a good chance these might show up on your test. Actually, they will show up on your test. Shear force. Like you don't know what that word is or what it is. So a shear force is when you push one way and there's another force that resists it in the opposite. So this is like Jell-O. It's what this is. So he's pushing on jello, and it's not actually accelerating that way because of friction's ability to resist it. And so that's called a shear force. And I can maybe look up the actual definition of shear. I don't know it word for word. If that would help you. Would that help you? Okay, I'll do that. Did you guys get this in? I'll get that real quick. Every other force you're probably fairly familiar with. Got it? Can I look it up for us? Yeah, this is probably not going to help you. It's a pretty wordy definition. A strain in the structure of a substance produced by pressure when its layers are laterally shifted in relation to each other. That probably doesn't help you much, does it?
Not at all. Ended up in the book.
What does the book say?
I'm almost there. SI, wait.
No, SH.
Oh, it doesn't have it.
Doesn't even have it?
No.
Doesn't surprise me.
Might be under force. Or it could be under shear force. Oh, wait, where's that? Look for it. Now I'm correcting me to back to
Okay, so here's what I say. The shear force is a very complicated definition. The only problem I would say is there are two forces. Maybe. I don't know. I'm not sure. Shear force usually doesn't give you it's complicated. It's hard to explain at this level. No, but the idea, yes. I hate when you guys ask questions that you're not really prepared for me to explain.
Like how mentaloids find, I still think that. Shear be if you're like standing. Yeah, it's like an earthquake, just like tilt. I don't know, I'm like thinking of a tilt. Yeah, I like to go a lot more than this.
I was good at Carly too at one point.
And I liked it.
Like an example of shear force actually happens with airplanes. When air along the front of an airplane wing causes it to actually rise. Here's all I want you to know about this at this point, just to save you the confusion. At this point, all I want you to know about shear force is that it's a type of contact force. I'm not going to ask you to define it. I'm not going to ask you to apply it. I'm not going to ask you to do any of that stuff. Moira, I'm talking. I'm not going to ask you, again, I'm not going to ask you to define it. I'm not going to ask you to apply it. All I want you to know at this point is that it's a contact force. I know that frustrates some of you, but we'll get to it later. Okay? Any questions about these other forces? Tension force, two things pulling on, usually some sort of string or something like that in opposite directions. Torsion force would be spinning, usually causes circular or centripetal motion. A compression, pushing on the plane of something towards the same direction. Right? I think we only have one or two more slides. The other type of force is a field force. Now these are fairly conceptual. It's weird to think of a force that can happen even though you don't touch. And you guys all, right now, are giving off a field force. Do you guys know that? Every one of us in here. What? No, breathing is actually contact force. Okay? Because it'd be me pushing the air molecules into contact with you. Good guess. Okay, so here's what I mean. Because you guys all know that all of you guys are attracted to each all of you guys. Yep. This is gonna sound bad. I don't mean to say boys are attracted to boys and girls are attracted. That's not what I'm saying. But technically, like I'm attracted to all of you. Not like that. Shane is attracted to all of you. Moira is attracted to everyone in here. Because each of us actually exhibits a field force. So before I tell you what that field force is, I'm curious if any of you guys can come up with a field force or a type. No? Magnetism is a field force. Any others? I can't believe you're not getting the one. No? Good guess? Gravity. Yes, that's the one I was thinking you'd get. And there's one other pretty obvious one. You looked, didn't you?
Yeah, I'm reading the book.
Yes. Gravitational forces, magnetic forces, and electric forces all cause an object to move without touching it. The one you're probably most make the most tangible sense is if you've ever dealt with two magnets, right? You have to touch the magnets to feel the force? No. Okay? Electric is probably the one you're least familiar with. Okay? Well, maybe not. You guys are you probably dealt with static electricity a little bit.
Every day.
Like, have you ever rubbed the balloon on your hair and then like lifted it off your hair and then what happens? Like your hair just all of a sudden whoop, right? Okay? Now, can a field force cause a contact force? Yes. Okay? Gravity is the one that all of us deal with every day, but we probably know the least about. And when I said I'm attracted to all of you, the reason why I'm attracted to all of you is because I have a gravitational field that you are in. So you're probably wondering, well, if I have a gravitational... Stop packing up. If I have a gravitational field, and you guys are in my gravitational field, you're attracted to me. You are. So you're probably thinking, why am I not just all of a sudden hovering towards the people I'm attracted to? Because we know a force causes what? Okay, well I haven't got to. A force causes an acceleration. So the reason why I'm not accelerating towards all of you, because I'm so attracted to you, is because I'm attracted to something a lot more. Anybody know what that thing is that I'm really attracted to? And you guys are all very much attracted to it? What'd you say? The Earth. The reason why the fact that we're all attracted to each other doesn't cause us to start going towards each other is because we're much more attracted to the ground, and the ground is much bigger and causes a much greater gravitational force than me to you guys. So, have a good day. I just said that everyone's attracted to everybody. I did. From a physics standpoint, please keep it context. Context is key in life and in biblical things. I'm attracted to Mason currently.
You're attracted to me.